Imagine, just for a second, that your own central nervous system, right? Like the way your lungs expand when you breathe, or the microscopic ways your blood pressure fluctuates.
Even the really subtle stuff.
Yeah, exactly. The rhythmic pulsing inside your inner ear. Imagine if all of that could be reverse engineered.
It's a wild thought.
Right. And I am not talking about, plugging you into an Apple Watch or a biometric monitor to just read your heart rate. I mean, taking the literal biological mechanisms that allow a human being to achieve a state of, well, absolute profound physiological stillness.
Pure silence.
Yes, pure silence. Taking that and mapping that exact biological architecture one-to-one onto a high-performance computer chip.
Right.
We are talking about a direct translation between ancient somatic awareness and, like, bare metal, cutting-edge ARM microprocessor engineering.
I mean, it sounds like a premise ripped straight out of a cyberpunk novel, to be honest.
It really does.
But the documentation we are looking at today is incredibly real. And it was highly classified until very recently. And technically, it's staggering.
Oh, completely staggering.
So today, we are executing a forensic cross-reference of a really specific biological remote sensing method. It's referred to in these files as the Type 3 method, or the custom etheric pulse.
The custom etheric pulse, yeah.
And our mission for this deep dive is to trace how the inventor of this method mapped it directly, perfectly, onto a deterministic silicon architecture known as CSR-138.
To pull this off for you, we've brought together this entirely unique stack of sources. I mean, we have declassified CIA manuals detailing coordinate remote viewing, or CRV.
Which was born out of the military Stargate project, right?
Exactly, the old Cold War stuff. We also have the highly technical, architectural patents for that CSR-138 deterministic silicon execution environment.
That's a mouthful.
It is, yeah. But the skeleton key to all of this, the thing that ties it all together, are these internal invention disclosure forms and transcripts of AI-human design dialogues. They act as the literal bridge between human physiology and silicon engineering.
And, the reason you, the listener, should care about this structural overlap is that it fundamentally redefines information security, like from the ground up.
Yeah, we are going to explore how the human nervous system can actually be hacked.
Hacked using precise breathing and rhythmic pulses.
Right, to function identically to a zero-latency hardware firewall.
And then we will look at how modern silicon chips are being intentionally designed to mimic that biological vagal break.
It is a masterclass in the elimination of noise.
It really is. It's the pursuit of a completely pristine state of data ingestion, whether that data is flowing through a living human operator or a Cortex-A53 microchip.
Okay, let's unpack this, because before we can understand the absolute genius of the solution...
The Type 3 method and the SASR chip.
Exactly. Before we get to the solution, we really need to understand the historical problem that plagued both remote viewers and computer engineers.
We need to wind the clock back a bit.
Right, back to the Cold War, to the early days of the Stanford Research Institute and military intelligence, because they were dealing with this massive problem, which is reactive error logging.
Historically, if military intelligence wanted to look at a denied target, right?
Like a secret base?
Yeah, let's say they needed the interior layout of a Soviet submarine base, and they were using non-local consciousness to do it. They didn't start out with coordinates.
No, they didn't.
They initially tried something called the outbounder method, or the beacon method. We can categorize this as type 1.
The beacon method always fascinated me. It's basically sending a physical human being, the beacon, to a specific location.
Right, boots on the ground.
Yeah. And then the remote viewer, who is sitting back in a shielded room somewhere in, Maryland, just tries to tune into that specific person's mind and nervous system, rather than trying to find a building on a map.
And there is a biological logic to that, actually.
Oh, for sure.
Because the human mind naturally locks on to other human biological signals way faster than it locks onto, abstract static architecture.
It's easier to find a person than a concrete wall.
Exactly. The viewer essentially piggybacks on the beacon. They read what the beacon feels, what they smell, what they see, but our sources point out a massive operational flaw with type 1.
They call it displacement.
Displacement, yeah.
Right, because humans get distracted. If you are the beacon standing outside a secret Soviet facility and you suddenly notice a really interesting stray dog wandering by.
Or you just start thinking about, the terrible coffee you had that morning.
Yes. The viewer back in the lab starts describing a dog or a coffee cup. The telemetry is completely polluted by the beacon's internal monologue.
But it's even worse than just bad data. From a counterintelligence standpoint, Type 1 creates an active two-way biological circuit.
A two-way street, yeah.
According to the declassified project notes, if the target site employed defensive monitors, essentially psychic sentries trained to detect non-local surveillance, they could literally feel the beacon being watched.
Which is terrifying.
It is. They could follow that active telemetry vector backward, right? From the beacon all the way to the viewer's physical location in the lab.
So it was highly vulnerable to detection.
Extremely vulnerable.
Which obviously forces the military to evolve. They realize they cannot use a human beacon anymore, so they develop Type 2, Coordinate Remote Viewing, or CRV.
And this is where the CIA manuals in our stack really get dense.
Oh, super dense. Because instead of tuning into a person, the viewer is given an abstract, randomized alphanumeric coordinate, just a random string of letters and numbers that represent the target.
And that transitions the process into a passive, one-way, closed-loop query.
Right, no beacon to trace back.
Exactly. There is no active transmission line for a sentry to trace. So the operational security was fantastic compared to the beacon method. But CRV introduced a whole new psychological hurdle.
The big one.
The big one. One that the CIA manuals dedicate hundreds of pages to solving, which is the problem of analytical overlay, or AOL.
I want to break down AOL because it is, frankly, the core villain of this whole story.
It really is the main antagonist here.
In CRV, right, the viewer sits down, they're giving a coordinate, and they instantly draw a split-second reflexive mark on a piece of paper. This is called an ideogram.
The physical twitch, almost.
Yeah, exactly. The goal is to capture the raw, energetic signature of the target through the autonomic nervous system before the conscious brain can even wake up and get involved.
But the human brain is, at its core, this relentless pattern prediction engine.
It hates ambiguity.
It despises it. When you feed it a tiny fragmented piece of raw data from an ideogram, let's say, the subtle physical sensation of something being cold, hard, and sloped.
The brain desperately wants to solve the puzzle.
It searches its memory banks and forcefully overlays an image.
It's an overeager autocorrect.
That's a perfect way to put it.
The viewer feels cold, hard, sloped, and the brain immediately screams, I know what that is. It's a submarine.
Right.
That is the analytical overlay. It's cognitive noise. And the crazy thing is, it feels incredibly real to the viewer.
Neurologically speaking, the documentation associates this with a 19 hertz high beta cognitive state.
High beta, yeah.
It's an agitated, highly analytical brainwave frequency. And the crucial thing to understand here is that the exact moment the brain makes that guess, the moment it says submarine, it completely stops perceiving the actual target data.
The connection drops.
It's gone. The viewer is no longer remotely viewing the Soviet base. They are remotely viewing their own imagination.
So how did the CIA fix this? Because, you can't just tell a human brain to stop thinking.
Well, they tried. They created a highly structured, rigid, 6-stage protocol.
The paperwork.
It was a defense mechanism based entirely on administrative documentation.
Yeah.
If a viewer was sketching and they suddenly noticed their conscious mind was trying to guess what the object was, they had to stop.
Stop completely.
They had to physically write down the letters AOL on their clipboard, write down the word submarine, declare the guess out loud to their monitor, lift their pen completely off the paper, take a physical break, and then start the whole process over, just to clear the mental buffer.
Okay, I have an analogy for this because reading that in the manuals was wild.
Let's hear it.
CRV is basically legacy antivirus software.
Oh, I like that.
Think about those old programs from, the early 2000s. They don't stop the virus from getting onto your hard drive. They let the virus in. They wait for it to start running amok and corrupting files, and then they flag it.
Right. They quarantine it in a little folder and ask you to reboot your system.
Exactly. The virus, the AOL, is already in the machine doing damage.
That is a brilliant way to frame it. And the internal documents actually refer to this exact vulnerability as the flaw of the clipboard.
The flaw of the clipboard.
The flaw is the underlying assumption that error is simply inevitable. The CRV protocol accepts that the 19 hertz cognitive noise is going to spark no matter what.
It just surrenders to it.
It does. It allows the brain to expend the biological energy to generate the false image, and only after the contamination occurs does the viewer go through the administrative steps to clean it up.
But I want to push back on this a little bit.
Okay.
Because looking at the CIA documentation in our stack, CRV had an 81.7% efficiency rating.
It did.
I mean, if 8 out of 10 pieces of data you pull out of thin air about a secret Soviet facility are completely accurate, isn't that a massive victory?
By most metrics, yes.
So why was the inventor of the Type 3 method so obsessed with fixing a system that was already working at 80%?
This raises a really important question about the nature of high-stakes intelligence environments, particularly what military strategists call the OD loop.
Oh, a DA, right. Observe, orient, decide, act.
Exactly. It is the cycle of decision-making in combat or espionage. And in the ODO loop, lag equals vulnerability.
Because the faster you cycle through, the faster you get inside your enemy's decision cycle. You beat them to the punch.
Precisely. So according to the AI-human dialogue transcripts included in our source stack, this reactive recovery method, the Clipboard, only scores a 50 out of 100 for operational security.
A failing grade.
A failing grade. Think about the latency. You are burning precious cognitive resources and, more importantly, time dealing with false data.
Right.
In a fast-moving operational environment where real-time telemetry is required, the 10 or 15 seconds it takes to realize you are guessing, write AOL on a clipboard, take a breath, and reset your posture. Well, that could be the difference between operational success and catastrophic failure.
The latency is the flaw.
The latency is the flaw.
And that latency is the catalyst for the paradigm shift. This is where we leave the Cold War clipboards behind and enter the bleeding edge.
The Type 3 method.
The Type 3 method, the custom Ætheric pulse. The inventor of this method looked at CRV and realized that managing errors after they happen is just a fool's errand.
It's too slow.
So they developed a personal protocol that claims a verified 95% data efficiency and a 95 out of 100 on security.
Which is astronomical.
And they achieve this by abandoning the paper entirely in favor of a proactive structural lockout.
It is a fundamental shift in philosophy.
Yeah.
We are moving from administrative software recovery to biological hardware gating.
Wow, yeah.
The Type 3 method alters the physical state of the human body so profoundly that it becomes physiologically incapable of producing the 19 Hz cognitive error in the first place.
The noise never sparks.
It never sparks.
But how exactly do you achieve a proactive structural lockout in a human being? I mean, you can't just flip a switch and turn off the analytical mind.
No, you can't.
To understand this, we need to dive into the foundational layer of both systems. We need to look at the biological mechanics of the vagal break, and then we are going to look at its exact one-to-one silicon twin, which is kernel silence.
Let's begin with the biology.
Okay.
The custom etheric pulse method discards the desk, the pen, the paper, all of it. Instead, it relies on manipulating the autonomic nervous system through a highly specific respiratory cadence.
The 20/12 cycle.
The 20/12 cycle.
The sources define this mathematically, and it's intense. The operator inhales rapidly, they hold the breath in the lungs for exactly 6 seconds, and then they exhale through heavy resistance for 4 seconds.
It's very deliberate.
Now, for you listening, if you have ever done tactical box breathing or even just deep yoga breathing, you know that breath control calms you down.
Sure.
But this is not about relaxation or mindfulness, right? The 20/12 cycle is a mechanical physiological trigger. It actively stimulates the vagus nerve.
And to understand why that matters so much, we have to look at how the body handles stress.
Right.
When you are awake and alert, your sympathetic nervous system is engaged. It's the gas pedal, keeps your heart rate up and prepares you for action. But when you deploy this specific 20/12 breathing ratio, you activate the parasympathetic nervous system.
The brake.
You deploy what physiologists call the vagal brake.
And the physical effects of that brake are immediate. When it clamps down, your heart rate plummets. Your blood pressure stabilizes into this flatline rhythm.
Everything slows down.
But the most important thing happening is actually in the brain. The vagal brake violently pulls the brain out of that agitated 19 Hz high beta state.
It starves the amygdala.
Yes.
The amygdala is the threat detection center of the brain. It is responsible for the fight-or-flight response, the microarousals, and those sudden spikes of panic that compel the analytical mind to guess and fill in the blanks.
To make the AOL.
Right. And the amygdala runs on adrenaline and cortisol. By clamping down the vagal brake, the operator physically halts the production of those chemicals.
So, if there is no adrenaline in the bloodstream, the brain physically lacks the chemical fuel required to manufacture an analytical overlay.
It can't do it.
It's like trying to rev a car engine when the fuel line has been completely pinched off.
Yeah.
You can press the gas pedal all you want, but the engine won't spark. The mental autocorrect is shut down at the hardware level.
And this is the exact moment where the crossover to silicon engineering becomes truly breathtaking.
It really is.
The creator of this protocol didn't stop at mastering human biology. They recognized that the biological vagal break was merely a structural concept that could be ported.
Ported to a machine.
They mapped this exact physiological state onto an ARM Cortex-A53 processor.
The CSR-138 architecture. Synthetic Aperture Signal Reconstruction.
That's the one. And foundational layer 1 of CSR-138 is the exact hardware equivalent of the vagal break.
Adaptive tick kernel silence. I spent hours reading this part of the patent, and it blew my mind.
It's brilliant.
But before we explain what kernel silence is, we have to explain how a normal computer works. Because normal computers are noisy.
Extremely noisy. In standard computer engineering, especially with standard real-time operating systems or Linux kernels, you have something called a scheduler.
Okay.
The scheduler acts like a hyperactive middle manager. It is constantly allocating CPU cycles, deciding which program gets to run next, and generating a steady, high-frequency tick or heartbeat.
It's like a metronome clicking 1,000 times a second. And every time it clicks, the OS stops what the processor is doing and asks, hey, does the mouse need to move? Does the network card have data? Do any other programs need attention?
And that constant checking creates what engineers call stochastic execution jitter.
Unpredictable micro delays.
Yes, a few nanoseconds here, a microsecond there. For normal computing, like browsing the web, you don't notice it. But for deterministic zero-latency execution, those micro delays ruin the absolute purity of the processing timeline.
So the OS scheduler is essentially the silicon equivalent of the human amygdala.
Exactly.
It's generating 19 hertz cognitive noise. It's an internal distraction constantly interrupting the flow of data.
That is a perfect structural mapping. So to eliminate this, the CSR-138 environment utilizes a very specific, aggressive Linux kernel configuration called config-HC.
Config no HC.
Right, but it doesn't stop there. It combines that with physical core shielding, known as isolcopus, and IRQ affinity masking.
Okay, I want to make sure I really understand this. Config no HC turns off the metronome, right?
Yes, it stops the scheduler's heartbeat on a specific core.
But what are the other two doing? Isolpus and IRQ masking. I know IRQ stands for interrupt request, but how does that actually manifest on the chip?
Think of it this way. Isolpus tells the operating system, do not schedule any normal user tasks on core 3. This core is quarantined. It is completely off limits to the rest of the system.
That creates the isolated room.
Right. But even if the room is isolated, hardware devices like a keyboard or a network interface, they can still send interrupt requests, or IRQ.
Oh, I see.
An IRQ is a physical electrical signal that taps the CPU on the shoulder and says, drop everything and deal with me.
So even in an isolated room, the phone is still ringing?
Exactly. Or rather, I should say, that is the flaw of standard isolation.
Right.
So CSR-138 uses IRQ affinity masking to route every single hardware interrupt to the other cores on the chip.
It unplugs the phone.
It unplugs the phone. It completely blinds the operating system to the designated execution core.
Wow. So just as the vagal break stops the human heart from spiking and eliminates the biological noise of adrenaline, Kernel Silence seizes control of the physical silicon execution pipeline at boot time.
It locks it down entirely.
No external threads can run on it. No hardware interrupts can tap it on the shoulder. No OS heartbeat can preempt its processing loop.
It eliminates pipeline stalls entirely. It creates an absolute non-volatile baseline state. The environment is perfectly isolated from any internal or external noise before the first piece of data is ever even collected.
For you listening, just take a second to process that takeaway. You are seeing how starving a human brain of adrenaline using breath control is structurally fundamentally identical to blinding an OS scheduler using kernel parameters.
It's the same mechanism.
Both systems demand a pristine void. Both systems create the ultimate clean room for data processing.
But, having a clean room is only step one. A clean room is useless if you don't put anything into it. Now that both the human nervous system and the silicon core have this pristine, isolated baseline, we have to move to layer 2 and layer 3.
How do they get the data?
Exactly. How do these systems actually ingest target data? And more importantly, how do they verify it without corrupting the clean room they just built?
Right, because opening the door to let data in is usually when the dirt gets inside.
It's the most vulnerable moment.
Let's look at how the biological operator handles this first. Our sources describe a process called target pinging.
Target pinging, yeah.
The human operator, deep in that vagal break state, they don't try to visualize the target. They don't look for a picture, because pictures trigger the analytical mind.
Right, that brings the AOL back.
Exactly. Instead, they use a psychological construct called a dark internal screen. They purposefully block any premature visual expectations.
They hold the alphanumeric coordinate in their mind, not as a physical location on a map, but as a raw, abstract geometric key.
Geometric key.
And they push this key down into their autonomic nervous system using the rhythm of that 20 by 12 breath.
The sources describe it beautifully. They call it whisper pinging the universal field.
Whisper pinging.
They send out this geometric coordinate through the central nervous system, and then they just sit in the void, waiting for a resonant echo. The internal screen stays totally, completely dark.
It's like active sonar pinging the bottom of the ocean.
Yes. You don't see the ocean floor, you just feel the acoustic return.
And how does the SASR-138 architecture mimic this delicate target pinging without letting external noise in?
Because it can't use standard memory. Right.
It cannot rely on standard memory fetches. It uses L2 cache-resident static memory mapping, specifically restricted to 512 kilobytes, combined with a technique called TLB pinning.
Translation look-aside buffer pinning. Okay, I read the Wikipedia page on this 3 times, and I'm still, a little fuzzy.
It's deeply technical.
Break this down for us. Why is TLB pinning the equivalent of the dark internal screen?
To understand TLB pinning, you have to understand how modern computers manage memory.
Okay.
Standard operating systems use virtual memory. It's an illusion. When a program asks for data, it asks for a virtual address. The CPU then has to look up where that data actually lives in the physical memory chips, the DRAM.
It's like looking up a name in a massive phone book to find the actual physical phone number.
That is a great analogy. That phone book lookup is called a page walk.
A page walk.
The translation look-aside buffer, or TLB, is a tiny hardware cache inside the CPU that remembers the most recent phone book lookup so it doesn't have to search the whole book every single time.
Oh, that makes sense.
But here's the problem. DRAM fetches and page walks, they take variable amounts of time.
They aren't consistent.
Exactly. Sometimes the data is ready immediately. Sometimes the CPU has to wait hundreds of nanoseconds.
And in a zero-latency deterministic system, waiting hundreds of nanoseconds is an eternity.
It creates massive timing jitter. It is the silicon equivalent of the human mind wandering.
Oh.
If the CPU has to wait for external DRAM, it loses focus, the pipeline stalls, and unpredictable latency slips in. So SASR-138 forces every single piece of the data structure, the entire execution environment, to fit strictly within the 512 KB L2 cache boundary of the Cortex-A53.
It refuses to use the external DRAM at all.
It absolutely refuses. And by enforcing a 64-byte alignment and locking the address space directly into the TLB, pinning it there permanently, the system memorizes the phone number.
It never has to open the phone book.
It never opens the phone book. It never talks to external memory. The memory access latency is hard-locked to the physical speed of the on-die L2 cache, which is mathematically constant.
So no external variable timing profiles can corrupt the silicon cycle.
The dark screen stays dark.
Here's where it gets really interesting.
A firewall.
The firewall. We have the clean room, we have the pinned memory, which is the locked door for the data to sit in. But how does the system know if the data it's holding is actually true?
Verification.
Right. What if the echo coming back is a clever decoy or just a stray hallucination? We need verification. This is layer 3. And the biological version of this is easily the most astonishing thing in the entire document stack.
You were talking about the 369 ear pulse harmonic.
Yes. The sources state that while the biological operator is sitting in that void, scanning the field with their dark internal screen, their primary focus is not on their mind.
It's on their ear.
It is on their ear. They are physically listening to the microvascular pulse of blood flowing through the artery near their right auditory nerve.
During the initial scanning phase, that pulse is just a steady, open heartbeat. It's a passive biological metronome.
But the exact moment their internal geometric frequency matches the actual target's frequency out in the universe, they achieve a physical phase lock.
The documents describe it as a somatic click.
A somatic click. It is a profound, localized physiological shift.
And what happens to the pulse?
The pulse near the right ear suddenly deepens. It shifts from a standard heartbeat into a heavy, resonant, unshakable beat based on a mathematical 369 harmonic ratio.
It changes rhythm entirely.
It throbs in a specific, undeniable cadence. And the protocol states that only after that physical lock is secured in the ear does the operator allow the dark screen to begin assembling raw textures, colors, and vectors.
They wait for the physical signal.
But here is the genius part, the actual firewall. If the operator's conscious mind tries to hijack the session, if they start guessing a submarine, or if a false target vector tries to bleed in, what happens to the body?
The human nervous system instantly registers a microarousal,
A microarousal.
a tiny, almost imperceptible spike in psychological stress.
Exactly, and that tiny stress spike instantly alters the body's vascular tension. The heavy 369 rhythm in the ear immediately stutters.
It desynchronizes.
The body literally flags and rejects the unaligned data with zero latency.
You don't have to recognize the error, grab a pen, write AOL on a clipboard, and take a breather. The firewall is autonomic.
Your own heartbeat stutters to say, nope, that data is contaminated, drop it immediately. It operates at a verified 95% data efficiency because it has absolutely zero tolerance for noise.
The physical body acts as a cryptographic hash, verifying the data stream.
It is a self-calibrating biological antenna. It is a masterpiece of human physiology.
It really is. And once again, when we look at this SR-138 bare metal architecture, we find the exact mechanical reflection of this pulse.
The silicon twin.
To achieve this zero-latency firewall in silicon, the designer faced a massive hurdle. They couldn't use standard software-based mutexes or locks to verify data ordering.
I know enough about programming to know that software locks are clunky.
Very clunky.
When multiple threads try to access data, software puts a lock on it so they don't crash into each other. But that introduces massive latency. The CPU has to execute software instructions just to manage the traffic.
Which means software locks are exactly like the CRV clipboard.
Oh, they are.
They are reactive, administrative, and incredibly slow. They waste execution cycles. So the inventor bypassed software entirely. SR-138 maps the biological ear pulse directly to the ARMv8 instruction set.
Hardware level.
Yes. Specifically, it uses hardware-enforced acquire-release semantics, the LDIR and STLR instructions.
Load acquire register and store release register. Now, how do these act as a firewall without slowing down the CPU?
Modern processors are designed to execute instructions out of order.
Out of order.
Yeah, if instruction A is waiting on data and instruction B is ready to go, the CPU will execute B first to save time.
Okay, that makes sense for speed.
But in a deterministic system, out-of-order execution is fatal. It's the equivalent of the biological mind jumping to conclusions.
It's the AOL.
Exactly. LDR and STLR enforce absolute, rigid state ordering at the physical instruction pipeline level of the ARM core itself.
It physically forces the electricity to flow in the correct sequence.
Yes. A store release, STLR, ensures that every single memory operation before it is completely finished and visible before the release happens. A load acquire, LDIR, ensures that no memory operation after it can start until the acquire is complete.
So it acts as a physical hardware fence.
Exactly. When you combine this with what the patent calls a sequential lock-free circular queue, you make it physically, structurally impossible for the chip to experience race conditions or out-of-order anomalies.
But the true elegance is how it paces the ingestion of this data, which mirrors the 3-6-9 harmonic rhythm in the human ear.
The modulo masking time gating.
The source text denotes this mathematically as TXOR12.
Yes, TXOR12. Traditional computer systems use hardware timers to pace their data ingestion. They say, check for new data every 1 millisecond.
Right.
But hardware clocks drift. They are physical quartz crystals. They're vulnerable to temperature changes, electromagnetic interference, and CPU frequency scaling.
They cannot be trusted for absolute determinism.
So SR-138 discards the concept of chronological time entirely. It tracks raw instruction execution cycles. It creates a mathematical pacing loop based purely on the sequential flow of pipeline instructions.
So, just like the biological operator's 3-6-9 air pulse stutters and immediately rejects a false, stressful thought, any unaligned or non-deterministic data states in the silicon are structurally rejected at the physical hardware layer before they can even be written to memory.
The architecture literally will not allow the instruction to complete if it does not fit the mathematical rhythm of the pipeline.
It's an automated architectural firewall.
The corrupt data is destroyed before it can ever touch the ledger. This is how the silicon achieves that exact same 95% efficiency, and it does it completely invisible to external OS monitoring.
Which brings up a massive glaring point.
The auditing problem.
Yes, we've talked extensively about how perfect this system is internally, but relying entirely on a subjective biological pulse in your ear or an isolated locked-off core inside a silicon chip sounds brilliant in theory.
In theory, sure.
The problem is proof. If I am the director of central intelligence, or if I am a corporate auditor reviewing a financial ledger, I cannot just take your word that your ear pulsed in a perfect 369 rhythm.
You cannot trust a black box.
You cannot trust a black box. We need a mathematical anchor. We need a way to prove that the data was ingested cleanly to the outside world without breaking the clean room to do it.
This leads us into the architectural necessity of mathematical validation and the ultimate failsafe, which is the F10 permanent ledger anchor.
The F10 anchor.
The inventor of SASR 138 was clearly aware of this auditing problem. They solved it by creating a dual-engine forensic execution environment. The patent refers to this as verification execution bifurcation.
I pored over the invention disclosure forms to understand this. There is an engine A and an engine B.
Right.
Engine A is written in bare metal C++ Psi. That is the execution layer running on the ARM silicon. That is the fast, isolated, zero-latency core we just spent all this time talking about.
The workhorse.
Exactly. But engine B is entirely different. It is written in Python.
Python, yeah.
It is a verification layer. It serves as a mathematical reference model and a Merkle tree registry. It acts as the ultimate source of truth.
Right, it tracks the hashes.
But honestly, when I first read that, I was confused. If the C++ layer is so flawlessly engineered, so perfectly isolated and deterministic, why not just write the verification and auditing system in C++ and run it on the same chip? Why introduce a slower language like Python into the mix?
If we connect this to the bigger picture of corporate intellectual property and global cryptography, it makes perfect sense.
Okay, how so?
It is about trust and commercial modularity. If every single line of code, both the fast execution and the slow verification, is locked inside a proprietary bare metal C++ environment, it remains a black box.
Nobody can see inside.
Nobody from the outside can audit the math without you handing over your highly guarded billion-dollar trade secrets.
You would have to expose the core IP just to prove it works.
Precisely. By separating the mathematical reference model into an open, readable language like Python, the creator established a composable forensic protocol.
A composable protocol.
Third-party auditors, governments, or client security teams can review the Python code. They can verify the exact logic, the cryptographic handshakes, and the Merkle tree hashing outputs against the raw data produced by the C++ implementation.
Without seeing the C++ code.
Where it can absolutely verify the protocol's deterministic purity without ever needing to see the proprietary C++ source code.
The sources mentioned this specifically enables field of use licensing.
Yes.
You could license the insane processing speed of Engine A to an aerospace defense contractor for missile tracking, and you could license the cryptographic auditing of Engine B to a cloud security firm for banking without ever compromising the core intellectual property.
It's commercially brilliant.
But that still leaves one massive loophole.
The problem of chronology.
Yes. Even with a beautiful Python reference model, how do you prove when this architecture was invented? How do you prove to an auditor that you haven't secretly gone in and changed the rules of the system after the fact to make the data fit your narrative?
You have to anchor the entire ecosystem to something completely immutable, something totally outside of your control.
Right.
This is the ultimate security constraint outlined in the documents, the F10 cryptographic anchor.
The unique system state hash. And for the record, the exact hash is F10EA7 D1AD589187EF5 5C9 5AE2988031172 FE1 5 FC 5SC 6F1 D DWAT173B8 036E.
It's a 64-character SHA-256 hash. And what the documentation reveals is that on April 18th, 2026, that specific unique hash was permanently burned into the global Bitcoin ledger.
Using an Aperture transaction, right?
Yes, Aperture.
Which basically allows you to attach a tiny arbitrary piece of data to a Bitcoin transaction, etching it into the blockchain forever.
Yes. It serves as an unforgeable proof of existence. It is carved in digital stone across thousands of decentralized nodes globally. No government, no corporation, not even the inventor themselves can ever alter or delete that record.
So how does that secure the SASR 138 system today?
It forces real-time state commitment. Any piece of data processed by the SASR 138 Engine A C++ environment, any remote sensing telemetry, any financial transaction, it must cryptographically correlate back to this F10 baseline hash.
Wow.
This ensures that the original 10-point execution logic, the kernel silence, the cache residency, the pipeline synchronization, it remains absolutely immutable and structurally pristine.
Because if it changes...
If a single line of code in the core engine is altered, the new hash will not match the F10 anchor on the blockchain.
The auditor instantly knows the system was tampered with.
The creator can prove unconditionally to anyone in the world that their system operated exactly according to the pristine math on that exact date without exposing how the engine actually achieves its speed.
Okay, let's step back and look at the masterpiece we've uncovered here. We have built the perfect biological receiver using the 2012 Vagal break and the 369 ear pulse.
Beautifully engineered.
And we have built the perfect silicon execution environment using kernel silence, TLB pinning, and pipeline synchronization.
The digital twin.
Both are flawless, zero-latency clean rooms. And the silicon is mathematically validated by the Python engine and the F10 anchor on the Bitcoin ledger.
It's a complete ecosystem.
But all of this begs the ultimate underlying question.
Why do both?
Exactly. If the biological Type 3 method is so perfect, if human consciousness, properly trained, can act as a zero-latency receiver with 95% efficiency, pulling data from anywhere in the universe, why is this silicon version even necessary?
It's a fair question.
Why go through the millions of dollars and years of engineering to build Cesar 138 if the human body can already do it?
This brings us to the final, unavoidable reality of the documentation. We reach the fundamental limitation of biology.
The physical limit.
And it is crucial to note it is not a limitation of space or a limitation of distance. It is purely a limitation of endurance.
Right, because as the sources point out, specifically referencing the declassified Stargate project data on non-local physics, physical distance is completely irrelevant to the human mind.
Distance means nothing.
Viewing a target 10 yards away in the next room requires the exact same biological effort as viewing a target on the dark side of the moon.
The accuracy of the data does not degrade over distance. The signal does not weaken. The limitation is entirely localized within the physical biology of the operator's own body.
The metabolic cost of the vagal break is astronomical.
It is incredibly draining.
Maintaining that 20 by 12 breathing cycle, manually suppressing your heart rate, holding that intense psychological focus to keep the internal screen dark, while constantly monitoring the microvascular 369 pulse in your ear. I mean, it is incredibly physiologically demanding.
It's like sprinting a mental marathon while holding your breath.
The internal documents outline a very strict, unforgiving operational window, 15 to 45 minutes.
45 minutes max.
That is the maximum biological endurance limit.
The human body simply cannot safely maintain a hyper-focused, artificially lowered autonomic state indefinitely. Physical fatigue sets in.
You literally run out of breath.
Shifting carbon dioxide levels from the heavy resistance exhalations force the brainstem to trigger an autonomic reset. Your body literally forces you to take a normal breath to avoid passing out.
And what happens chemically when you hit that wall? The sources note that glucose levels in the prefrontal cortex deplete massively from the intense concentration.
When cognitive resources deplete, the brain goes into survival energy-saving mode.
And in energy-saving mode, the analytical mind, that pesky 19 Hz AOL autocorrect we discussed at the very beginning, it aggressively takes over.
It floods back in.
It is vastly more energy efficient for the brain to just imagine a picture of a submarine than to actively hold the void and scan the universal field. You lose the true signal entirely.
Not to mention the vulnerability to biological signal decay from the outside world.
Oh, right, just normal distractions.
You could be perfectly locked into the vagal state, retrieving pristine data at minute 40, and suddenly a door slams in the hallway outside your lab.
Or the air conditioning unit kicks on.
Or you just get a random muscle cramp in your leg.
Any sudden external interruption spikes your blood pressure immediately. The amygdala dumps a micro dose of adrenaline into the bloodstream.
And instantly, the 369 harmonic ear pulse breaks. It stutters, it desynchronizes, and the connection drops.
The biological firewall does its job perfectly by shutting down the corrupted session, but the reality remains the session is over.
The data stream is dead.
This is the exact vulnerability that the silicon architecture was born to solve. The documents call it silicon permanence.
Silicon permanence. And that is the true relationship between these two systems.
So what does this all mean for the future of technology and human potential?
It means that the human nervous system, when disciplined, is an incredibly powerful zero-latency receiver. It can act as a perfectly tuned antenna to filter the universe's data, bypassing the constraints of distance and time, recognizing truth through a physical somatic harmonic pulse.
But it is fragile.
It is fragile. It can only hold that pristine state against the chaos of the universe for about half an hour.
And that is exactly why the Cesar 138 architecture and the F10 ledger anchor were engineered.
Yes.
The ARM Cortex-A53 It does not get tired, it does not run out of glucose, it doesn't get startled by a slamming door, and it doesn't need to breathe.
It can run forever.
The SSR-138 architecture is designed to capture, mathematically validate, and permanently hold that pristine, deterministic state indefinitely. It takes the baton the exact millisecond the biological endurance limit is reached.
The human operator provides the access to the non-local data. The silicon provides the permanence to anchor it in this reality. They are not competing systems.
No, they work together.
They are two halves of the exact same structural paradigm, perfectly mirrored across flesh and metal.
We have covered an incredible amount of ground today. We started by looking at the flawed reactive legacy of coordinate remote viewing, relying on a clipboard and waiting for the brain to make a mistake before cleaning it up.
We saw how shifting to a proactive biological lockout, using the 20 by 12 Vagal to physically starve the brain of adrenaline, eliminates that cognitive noise entirely, stopping the error before it can spark.
And we mapped that biological vagal break directly onto ARM Cortex-A53 silicon. We saw how adaptive tick kernel silence and IRQ masking blind the OS scheduler, creating a perfect jitter-free clean room.
We explored how TLB pinning mirrors the dark internal screen.
And how the 369 physical ear pulse perfectly matches the ARMv8 acquire-release pipeline synchronization, structurally rejecting false data with absolute zero latency.
All of which is mathematically anchored to the real world through the Python verification layer and the immutable F10 Bitcoin ledger hash, ensuring the entire system remains pristine and verifiable even after the human operator hits their 45-minute physical limit.
It is a stunning synthesis. It takes ancient somatic awareness and fuses it with bleeding-edge microprocessor engineering. It completely redefines what it means to process information securely in a noisy world.
It truly does. It shows us that as we push technology to its absolute limits, the most advanced architectures we can conceive might just be mirrors, reflecting the hidden potential of our own internal biology.
I want to leave you with a thought to ponder long after this deep dive ends. We talked heavily about the 369 harmonic, that microvascular pulse near the right auditory nerve that acts as the ultimate truth filter for the universe.
The somatic click.
Right. The next time you are lying in bed or sitting in absolute stillness and you feel your own pulse throbbing in your ear against the pillow, ask yourself, are you just feeling your blood pressure? Or are you actually listening to a biological algorithm, a zero-latency firewall, just waiting for you to feed it the right coordinates?
A fascinating thought to end on. Thank you for exploring this architecture with us.
Thank you for joining us for this deep dive. Until next time, stay curious.